So what we're going to do right now is we are going to work on simplifying rational expressions. Rational, the first 5 letters of the word rational spells the word ratio, and we should know that the word ratio refers to things that are like a fraction. We even talked about them being sort of like a proportion written with a colon, 2 to 3, but that's the same as saying 2 over 3 in a sense. So rational expressions don't have equal signs. It is very important that when you take notes on things like this, that you write down a header and that you write down directions. Because, and I know some of you are like, I don't need to, I'm amazing. But you do, because the directions are going to give you those key words. So above my head, I have a bunch of words: evaluate, find, solve, verify, simplify, the words exact versus approximate. These words in directions on any math problem on an SAT, a college placement test, or regular test, a life example, like you're doing something. These words are indicators of what you need to do and what you're not allowed to do. So sometimes you're going to be like, I tried, to multiply everything by 24 and, it worked in that other example. How come it doesn't work in this example? Because they're not the same kind of problem. You can't multiply everything by 24 in an expression where you're adding and subtracting. You can multiply a fraction by 24 over 24. That's cool. Because what is 24 over 24? 24 over 24 is 1. The multiplicative identity. You're not changing anything. But when you multiply an entire expression by 24, you're changing it. Take your age and multiply it by 24. It's not the same. But now take your age and multiply it by 24 over 24. That means multiply it by 24 and then divide it by 24. Same thing. Nothing changed. So there is a big difference between those two steps. So you need to know that those aren't the same thing and that they're different. And you need to know that there's a time and a place for each. So the only way that you'll have a good point of reference is if when you take notes, you put a header on your paper, you write down the directions, and you write down the original problem. You're only saving a few seconds of your time by writing a couple scribble scrabbles on your paper, but in the long run, it's supposed to be a note for yourself to look at later when you're doing homework or practice or a real life example. So example 1, I'm going to write the directions, and the directions are going to say simplify. In a really nice world, they would even say simplify by blah, blah, blah. And they will straight up tell you what to do to simplify. But that's not real life. When you have a problem in life, usually the main blanket approach or thing that you want to do. You want to simplify this. All right, we're going to simplify it. But you just don't know how you're supposed to simplify it. That's on you to figure out. So we're going to simplify this expression. And what you need to do in your brain is think of it like any other fraction, all right? If you had a fraction like 12 over 4, and I said to you, simplify that, how would you simplify it? Take that method and try applying it to this method. Now, let's talk about what really goes on when you simplify that 12 over 4. If you factoring is really so important. Every time you solve anything, you're probably going to set it equal to 0 and factor. Like 90% of the time, 99% of the time. The only times you don't really set it equal to 0 and factor is like if you really only have a plain little x in there. It's like a linear expression, maybe exponential, blah, blah, blah. But most of the time, you're going to factor if you can, because you're going to find all the answers using zero product property. Even when we simplify, so not just solve, but simplify. But we can't set anything equal to 0. We don't have an equal sign. We're going to factor that 12. Now 12, could you simplify it like halfway and just say 12 is really 4 times 3 and 4 is really 4 times 1? Yeah, honestly, that's acceptable. Then anything over itself is 1. So what happens to that 4 over 4? It's a 1, and we don't need to write it. And we're only left with 3 over 1, but we don't need to write that 1 either. So we just get 3. So we start here, we go there, and we go there. But could you have simplified it a little bit more intense, like a little bit more intense math there? Sure. If you were a little bit more intense, instead of just 12 being 4 times 3, you could really break it down. 2 times 2 is 4 times 3. And on bottom, 4 is really 2 times 2. Well, here we got a 1. Here we got another 1. And remember, when you look at this, I don't have any adding or subtracting. No. No adding or subtracting is anywhere visible. Do you see any? I don't see any. I just see multiplying and dividing. That's it. That's it. No plus signs. No minus signs. Could a number be negative? Sure. That's not minus. Negative, context clues, okay? Then 1 and 1 are gonzo, and we get 3 again. Let's apply this same approach to this. We got to factor. How do I factor? I don't care which one you want to be able to factor. How do I factor the top? How do I factor the bottom? X squared minus 4x minus 12 or x squared minus 4. One of those things is super easy to factor. Super easy. So you could just go ahead and shout it out to me. Go ahead, Paige.
So the denominator would be the difference of 2 squares?
Absolutely. The denominator is the difference of 2 squares. If you heard what Paige said, and that's something that you should make a note of, guess what? You're going to put a little note. Difference of 2 squares, okay? Make a note of it. So go ahead, Paige. What does that mean? This is the difference of 2 squares. Difference, subtraction, perfect square, and a perfect square. So what are we going to do about that?
That means that you have to add 4 to like 0. I think that's what you did.
Who could help Paige clarify? How do we factor the difference of 2 squares? How do I factor?
Oh, you find
like 2 squares.
So elaborate again. Sorry, Jabari, go ahead.
You basically have 2 parentheses, and then you'll be like x plus or minus 2. So x minus 2 and 1, and then x plus 2 and the next one.
That's correct. So basically, this is where we have our little bit of our x-ray vision again, and we just kind of look at this and we think like, what's being squared minus what's being squared, and then we have one that's a minus and a plus, and we know that word. I'm going to ask you about it. That describes when you have 2 expressions, one's plus and one's minus. The magic word, Manuel, or Hashara, or Justin, or Melvin, to describe that type of expression, those types of expressions together. Soul. C word. What are they? Come on, guys. I literally ask you every class.
Conjugates.
Thank you. I heard conjugates. Good. They're conjugates. So there we go. What about the top? Who knows how to factor that numerator, or at least what method you need to use? Give me something there. How do you factor that numerator? What is it factored? What method do you use? What do you know about factoring that numerator? Factoring that numerator. I only see one hand up, but maybe Marta, Isa, Adriana, Dylan. Go ahead, Adriana. What do you know about it?
AC method?
Absolutely. We can use the AC method. A is 1. C is negative 12. 1 times negative 12. Now, maybe you did it on the side already while I was blabbing. You had to figure out what multiplies to give me 1, to give me negative 12, but adds to give me the middle term, which was negative 4. And if you forgot how to factor like this, you have to come for some extra help, okay? So what do we get for the numbers? How do I factor it? Who could kind of get us moving on this? How is the top going to be factored? Anybody got it?
Negative 6 and 2.
Negative 6 and plus 2. That's what we would use if we split the middle, and then we would do grouping. But whenever this is a 1 in front of the x squared, the shortcut is there's the negative 6 and there's the 2 plus 2. We could just jump right to it for a shortcut only when a equals 1. Now, we factored. I did not show the work, okay? Need to see work. See me for extra help, okay? Next step. So that's the next one. We went from here, and here. Now look at what we did. To simplify those on the side, we factored essentially, and then we reduced. Look carefully at what we have. Everybody's attached by multiplication. Is there addition and subtraction inside of the parenthesis? Yes. That's okay. Listen again. Is there addition and subtraction in this problem on top and bottom? Yes, there is. But it is inside of the parenthesis. That's different. Okay? It's inside of the parenthesis. That is different. What do you think, be a brave soul, what do you think, based on what we did over here, we should do here to go to my next step? What should I do? What should I do? Amelia maybe knows, or Isa, or Ella, or Marta. We got 1 minute. No, Ashara. All right, I see that you got your hand now. I'm just gonna move along here. We have an x plus 2 on top, and we have an x plus 2 on bottom. It is a factor on top and bottom. It is something over itself. Anything over itself equals 1. Even an x plus 2 over x plus 2. That is a big blocky 1. And what am I going to do with that? Cross it out. We don't like the word cancel. We like the word reduce. We like the word simplify. What does that leave me with? That leaves me with x minus 6. That leaves me with x minus 2. And we are done with this. Nothing else to do. So this is simplified, but we have one last step that we're going to write down. We're going to write the word restrictions. Because we have an x, which is like a wild card. An x is a variable where it can vary and change. We need to write down 2 numbers in this example that x should not be allowed to be equal to. Because if we let x equal those things, my denominator will end up being equal to 0. And that's a crime in math. The denominator cannot equal 0. What numbers is x not allowed to equal because they will make my denominator equal 0? Look at this bubble, this parenthesis. If I fill in what number for x, will it make that bubble equal 0? Just shout it out. Go ahead again.
2.
Yeah, 2. And what number will make that parenthesis, the other one, on bottom? Only the denominator, because denominators can't equal 0. We'll elaborate on this more next time, but what number will make that denominator bubble equal 0?
-2.
-2. So those are my 2 restrictions. So as long as x is not equal to 2 or -2, the way that this becomes simplified is this. You do not cross out the 4s. You do not reduce the 4 and the 12. You do not cross out x squared. I never said you cross out x squareds from top and bottom, but will somebody try that? Probably. Did anyone tell you to do that? No. Why are you doing that? Because you weren't listening and you're lazy and you're just doing something that seems obvious. Don't be that person. All right? So there's your simplified answer. Those are our restrictions. We're going to put a note. Denom can't be 0. And we're going to talk about that part next time. You're going to make sure you have this all written down. And you are going to turn that in for notes for classwork today. And I'm going to post on Classroom in a few minutes a few examples that I want you to do. I know class is essentially over, but I am going to write down what the homework is now for anybody who wants to just get it down since your next class doesn't start for 15 minutes. So your homework is going to be more simplifying, just like those. Simplify all. Number 1. Number 1 will be x squared minus x minus 6 over, and then we'll also put state restrictions, over x squared plus 8x plus 16. Number 2. X squared minus 2x minus 3 over x squared minus 7x plus 12. Oops. Number 3. X minus 2 over x cubed minus 8. And number 4. Last one, x to the 3rd plus 3x squared minus 2x minus 6 all over x cubed plus 27. Remember, you might want to go back and look at the 5 factoring methods. If you want, I can try to post the videos of the factoring methods from earlier this school year, and that would be helpful. And you're going to upload this homework before our next class. If you need to see me about your recent assignments that maybe you missed something, you're going to come by after school or stay after class now. But that is the end of this video, and I hope that we all try our best on these examples.